Up next is Wyatt Brown, a master's student in civil engineering. His presentation is titled, Roundabouts Are Dope, but Are They for Bicyclists? Please join me in welcoming Wyatt.
Roughly 40,000 people die each year on our U.S. roadways.
That's more than aviation crashes, natural disasters, and mass shootings combined. And rightfully so. Those three topics garner a lot of our national attention and interest. However, I think there's another major problem that exists right in front of us and is something that we really need to start paying attention to. And where do a lot of these fatal crashes occur at? Intersections. Intersections are a confusing place. You've got vehicles, bicyclists, pedestrians, all with potentially conflicting movements, maybe at high speeds, leading to some dangerous potential outcomes. And if you ask me, Wyatt, how should we be designing our intersections nowadays? I'd tell you, we should be using the roundabout. Roundabouts are pretty great. They improve the safety for vehicles and pedestrians, but not necessarily for bicyclists. And so that's what's led me to believe roundabouts are dope. But are they for bicyclists? Today, I'll be going over 1, the benefits of roundabouts, 2, the challenge they still pose for bicyclists, and 3, my research looking at 3 roundabouts in Washington County, Oregon. Roundabouts offer a wealth of benefits in comparison to traditional signalized intersections. They're clearly more aesthetically pleasing. They have economic and cost savings for communities. They improve traffic flow and efficiency, and most importantly, they improve safety. Research has found a reduction of injury crashes of up to 80% for vehicles and 75% for pedestrians. This is because at traditional intersections, the angle of crashes is far more severe. You've got the potential for left-turning vehicles to be T-boned by oncoming traffic, or even the potential for head-on collisions. However, at a roundabout, the angular geometry makes it so that the worst type of crash you might see is a side swipe or a rear-end collision. Also, this angular geometry significantly slows vehicle speeds, thereby significantly improving vehicle safety. This reduction in speeds also improves pedestrian safety. And roundabouts designs makes it so that pedestrians only have to cross 1 lane of traffic at a time, which sounds pretty dang nice if you've ever tried to cross brutal 9th Street or even slightly sketchy Monroe. The higher bicyclist crash frequency is due to roundabouts design making it so that bicyclists either have to take the driver's lane and act as a vehicle and potentially conflict with vehicles, or to take the long way around on the separated path and conflict with pedestrians. The ideal design for roundabouts and bicyclists at roundabouts is to have a separated bicyclist path that is separated from both the vehicle driving lane as well as the pedestrian walkway. However, most roundabouts do not have this and still face bicyclist safety issues today. My research is looking at 3 roundabouts in Washington County, Oregon. 2 of these roundabouts, as you can see on the screen, have been designed so that currently they're supposed to operate as a single lane roundabout. However, they have this extra space and a closed lane so that in the future they can be opened to double lane. I'm also looking at a 3rd roundabout that's more standard conventional design, and this is a single lane roundabout, and we're using this to benchmark our findings from the 2 unique roundabouts with. Myself and a small army of undergrads have gone through 1,400 hours of video footage and have observed 729 bicyclists. We've even seen someone on a tandem bike, someone on an elliptigo, and even someone on a horse. While we couldn't quite count this person on a horse as a bicyclist, it was pretty dang interesting nonetheless. And the results have been interesting too. Typically, roundabouts are thought of as having 4 conflict points at each leg between vehicles and bicyclists. However, our research, we've observed 9 different locations where these conflicts have been observed, as you can see with the 9 dots on the screen. The 5 colored dots are the locations of the highest frequency. And looking specifically at the red dot on the screen, this is the location at the standard roundabout where we saw 49% of all conflicts, and they were between a merging vehicle failing to yield properly to a circulating bicyclist. Again, looking at the beautiful dots on the screen, this time looking at the blue dot, This is the location at the unique roundabouts where we saw 53% of all conflicts, and they were between a vehicle overtaking the bicyclist on the exit leg. Also, at the standard roundabout, we saw that 9% of all bicyclists experienced a conflict with a vehicle while going through the roundabout. This was almost doubled at the unique roundabouts, where we saw 17% of all bicyclists experience a conflict with a vehicle while going through the roundabout. These results tell us a lot about how different roundabout designs impact bicyclist safety at roundabouts and how vehicles and bicyclists interact at roundabouts. We can use these findings to improve general roundabout designs for bicyclists, and we can also propose real-world modifications to the Washington County engineers to improve the bicycle safety at these unique roundabouts. My passion for transportation is rooted in one simple goal: reducing those 40,000 lives that are lost each year on our US roadways. By improving bicyclist safety at roundabouts, we can get one step closer to achieving this goal, and we can start saving real human lives today. Thank you.